Hi folks, this is a crash course video on essentials of the assembly design workbench. Now, in the next week or so, we will be solving several assembly problems, except that it has been a year since we did this stuff from the CAD point of view, and you may have forgotten some of the key points. So I'm going to do several of these problems, or at least today, just this problem, in an expanded way. When I'm supposed to do this problem in the class and analyze it for stresses, for example, if the bottoms of these bearings are clamped and then you put a load on the top of the stand, you have to create the model. And I don't spend more than 5 minutes, 5-10 minutes at most to do this. So here I'm going to do it in a very relatively expanded form, short. I take my time, and it may take about half an hour, 35 minutes. So at least you get to know what is it that you have forgotten, okay? The only difference between this problem that we're going to be analyzing soon in the class and the one that I'm going to create as a model for you, as a CAD model for you, is that there's a little stand that I put here because essentially at some point in the class I'm going to put a load on that stand and the bottom of these bearings are fixed and this shaft obviously is going to deflect. So I'm going to add this stand to it. Okay, so the first thing that you do is you start with the product file. Let me see now, product file, and let me save this thing, file, save management. There's nothing in it, but we can still save it. Save as on my desktop, a new folder, and I call it assembly design, crash course, and so this product is going to go into that folder. Now, if you want, you can go and create 3 parts and then bring them in here. That's called the bottom-top approach, but I'm going to do it as in the top-down approach. In other words, while I'm in this environment, I'm going to create all my parts. So insert a new part in there, and I'm going to call this thing left bearing, properties. This is left bearing. This is the instance name, and you scroll down. This is the part name, left bearing. Okay, let's make it. So double click on this. On that vertical plane, on this vertical plane, I will sketch something that looks like this. Okay, so do it any way you want. So here's how we're going to do that. Okay, make sure it's nice and symmetric. Left line control, left line control, right line control middle axis. You make it symmetric. Okay, and let's put some dimensions here. This is 2. This radius is 1. You need a little circle inside. The radius 0.5. And exit and pad it in each direction by 0.5. But mirror extend, so that gives you total thickness of 1. Now this is my left bearing. Now the right bearing is exactly like that. So if you want, you can do a copy paste, or after you save this product, go all the way to the top level, click on the floppy, and you notice that in that folder you have the product and left bearing. Of course, left bearing and the product. There we are. Okay. Now, after you save it, you can insert an existing component, namely the left bearing. That's one way of doing it. Or you can, the problem is that if you copy and paste and you save it, that right bearing is not going to appear here. So what I'm going to do instead is I'm going to insert a new part. It's very simple. This is not an efficient way of doing it, but I'll do it. So that's going to be right bearing, and this is the instance name. Here's the part name, right bearing. Okay, and we can double click it. Now, before I do that, if you go all the way to the top, and click on the floppy, what will happen is that this right bearing will appear in that folder too. Now, please remember on your test day, right, on the test day, you have to give us the product, left bearing, right bearing, and the shaft that I'm going to make, and the CAD analysis file, if this was actually a test problem. Okay, so let's go here. We're going to make it now. Double click on right bearing. I know this sounds crazy because the other guy is just like that, so why should I make it? And you don't. However, we decided to do it. We'll draw something like this on that same plane, which was this plane, okay? Now, there are different ways of doing it. I'm going to do it the lazy way. In other words, I'm going to project these guys on that plane and then just pad it, okay? This is the lazy way, so I'm going to create a different, so where is the project? Right there, project. You project that profile, that entire profile is going to be projected all at the same time. And you can hide this. You can see that actually it gets projected, and then you exit, and then you pad it in both directions by 0.5. Okay, there we are. And if you go all the way to the top level, and you click on the floppy, this is going to be saved. So you can see that already. A product, left bearing, right bearing, after it's made, they have been present. Now, where's the other guy? So the other guy is right here. If you go to the hidden zone, the other fellow is in hidden mode. Okay. If that's not doing it from here, let's go back there and do the different way here. Right click, hide and show. There. They're sitting on top of each other. And if you wonder how we're going to move this, you can use the compass, you can explode the view, or you can use the move and manipulate move toolbar and the manipulate icon and translate these things in any direction that you want. For example, I'm going to take in the direction X, I'm going to move that thing, and you can see that there's the left bearing, or this is the right bearing, this is the left bearing, you can see that, and we're going to do that the rest of the problem. Good. So we go all the way to the top, insert, new part. This says that you're creating a new part. Do you want this part to have a new origin, or should I use the assembly origin? I always say no, use the assembly origin. And I'm going to call this thing the shaft. Right click properties. Properties, this is the instance name, shaft. Shaft. And shaft. Right there. There's the part name. Shaft. Okay. Good. And we can make it now. Double click on the shaft. For example, on this plane, sketch. Okay. The sketch, and why don't we project that circle? So you're going to go and project that circle. You can see that it's projected. Exit, pad it by 10 inches. So this is going to be the shaft that we want, except that there's no stand in the middle of it. Okay. Now, I want the stand to be exactly in the middle, so there are different ways of doing it. It's entirely up to you how you want that thing to be done. Let me show you one way. first of all, let's go all the way to the top, all the way to the top. And now I'm going to move this shaft a little bit to the left of it. So under the move toolbar, here's the manipulate. Let's translate this thing in the X direction a bit more, right there, so it doesn't block my view. Now, I was not thinking when I did this, but that's okay. You don't know how you're going to do that. So the situation is like this. For example, I'm going to create a plane right in between this point, this plane, this end plane, and this plane. And how can I do that? For example, let's see if this thing works. We go to the part design. We go to the part design. We go to the shaft, part design, right there. And let's create a plane, reference plane from that end in the other direction, 5 inches. 5 inches, right there. So this is exactly in the middle. And to make that circle, there are different ways. You can draw a circle and pad it, or you can draw a rectangle shafted. That's what I'm going to do the way I created my plane. This is how I'm going to do that. So on that vertical plane, I will sketch right there. I will sketch. If these are bothering you, you can hide them right there. I'm going to draw a rectangle like that. I'm not even sure if this is actually on that. It looks like it's coincident. Good, good. And exit, and then shaft it about that. There we are. Whoops. It was not in the middle. So let's go ahead and clean it up. So it was this sketch, right? It was this sketch. Oh yeah. Actually, I wanted to shaft about this axis, correct? I selected that axis by mistake. So let me exit, double click on the shaft. For the axis, I select for the axis, let me delete, let me see now, clear selection. I select this, that's much better, very good. Okay, you create something like that any way you want. So go all the way to the top, click on the floppy, everything is going to be there. So let's bring those things that are hiding to our view mode. So hide and show. Now if it doesn't come when you do this, maybe you should go and do it from the tree. Hide and show. Now this path is hiding. Hide and show. Okay, and hide and show. Okay, good. Now these are basic operations that you should have mastered when you took the course last year after taking the course. Okay, now let's save everything. Well, it's already saved. Now we have to put these things together. Whenever you put things together, it's a good idea first, or assemble, first fix something, anchor something, so that at least that thing is remaining in space stationary. This is the anchor. Constraints toolbar is absolutely essential. The next 6 weeks, the 6 weeks after the midterm, is going to be all about this stuff. Okay? No finite elements, all about this stuff. And of course, there's more to it, mechanisms and things like that. You click on the anchor, you select that, that's going to stay stationary, no problem. Now, I want to put, just to show you, I'm going to move this thing up a little bit and make a crazy rotation like that. Where is that? Rotation. Like this and like this. Okay, very good. So I want to put this shaft inside of that hole. So we do coincidence, this axis and that axis, and there's an update here, manual update. You click on it, that's what's going to happen. I want to put the end of this coincident, make it coincident with that, and update. There we are. And same thing on this side, coincidence between this axis and that axis, update, and coincidence between this plane and that plane, update. Now, If I move these things apart, let me show you. If I move these things apart, for example, translate this thing in direction Y and Z, where's that Z, and do the same thing here, and translate it in X. When I update, they're going to go back to where they're supposed to be, except that these are not actually fully constraints. I'll show you why. Because let's move these things one more time. I'm going to move this thing up, no problem. And I'm going to move it a little bit this way, but I'm also going to rotate it. For example, rotate it about this axis, rotate it about x-axis, actually. Let me try that. There. I say OK, and update. This was fine, but let's try to do something else. Let's move it again. Up, this is rotation. Rotate it about this axis, okay? Rotate it about this axis. And say update. You see? Because these are not fully constrained. So for example, what I want to say is there is an angle constraint between that face and this face. And that angle 90 degrees, and it stays 90 degrees, okay? Let's do the same thing on this side. Angle constraint between this face and that face. We want to make it 90 degrees because I rotated, it's no longer 90, and update, and it's going to go back. Now, if I do crazy rotations, for example, this is a rotation about an arbitrary direction like that, okay, and maybe I move it up too, and maybe I move it up, and I update, it should go back to where it was. That is fully constrained, okay? So I did a crash course for you. By the way, you can, sometimes you may want to explode the view so that instead of moving, you can have access to other things, but here's the explosion, apply, and there we are. Instead of moving and things like that, you can do it like this. If you feel that you need more practice, you really should go to some of the excellent websites by other people, YouTube website, and see some very basic assembly operations and constraints. Really, making the parts is not a big deal. Our parts is relatively simple, but these are important. You can get away not knowing them for the first part of the course, namely the finite element, but when we go after the midterm, it's absolutely essential for you to, if you did not master this thing in your advanced engineering design course, learn it now, because that second part of the course is all about mechanism joints, which deal with this toolbar constraints. Good luck.